First laboratory work, it's about constructing an input-output model. So today we are going to talk about one of the classical macroeconomical model which describe different relationship between different branches of economy. And this model was developed by one of the famous world economists, you know it, it is Vasily Leontiev. And in economics, an input-output model is quantitative economic model that represents the independencies between different sectors of national economy or different regional economies. And Vasily Leontiev earned the Nobel Prize in economics for his development of this model. So to provide the explanation of this model, I want to start from the most important assumptions. Because remember that all kind of models always must based on some of assumptions. Why? Because in such a way we simplify the necessary calculations. It would be really too complicated, even mathematically, if we include too much factors, and also unreasonable because we take a lot of time and other resources. That's why before we start talking about these key assumptions, I want to define the main goal of building this input-output model. So the main goal is to understand how many products each branch of economy must produce to provide all demand on these products from not only final consumers, but also from other branches. And to understand clearly what I mean when I talk about this main goal of this input-output model, I wanted you know the main participants of this model, the main participants. So, first of all, we talk about different branches, different sectors of economy. And some of them could produce, for example, textile, some labor, steel, food, etc. Next, at the same time, each branches can be supplier and client for each other. Simple example, if we talk about automobile manufacturer or automobile sector, we understand that to produce a car, what we need? We need a steel, and it gives us steel branch. What we need? We need also electronic, and it produces for us electronic sector. We need glass, we need textile. So we are clients for these branches. And these branches are suppliers for us. And we are their clients. But from other hand, we produce the cars, and that could be sold not only to final customer, me or you in a car showroom, but also we can sell this car to another branches. For example, we can sell it into transportation branch, some logistic companies, or we can sell it to agriculture sector. And for these sectors, we are not client, we will be what? We will be supplier. So each kind of branch or sectors of economy into this model we describe like supplier and client at the same time. That at the same time we can be supplier for other branches and for the final consumers. But to produce some products, we also need to be clients for products from another branches, and we are clients and we are suppliers at the same time. We have final consumers. Who is final consumers? It is you, it is me. So it is anyone who do not produce anything, just consuming yeah, final goods. It is final consumers. So it is the most important participants into our model, input-output model. So it is different branches of economy. They could be at the same time and supplier and clients, and it is final consumers who consuming final goods and do not produce anything. So if it is understandable, you are ready to get to know what are the basic assumptions. So the first basic assumptions that we talk about closed economy without influence, import or export. So we talk in this model only about closed economy without influence of export and import. Next assumption, economy is in balance. So all what we producing must be consuming. We have no extra products. We have no some deficit of products. So we have balance of our economy. And of course, it's some idealistic situation because it doesn't happen in our practical life, even in the most developed country, but it is our assumption in this model. Next, the third one. We describe economy as a system with huge number of sectors, and the main our task it is understand relationship between them, between these sectors who play double role in economy. So they can be suppliers and consumers at the same time to each other. And each branch produce only one product. So our task is to understand the relationship between sectors, and we know that each our branch play double role. At the same time, it could be supplier, it could be clients. Good. It is third one. And the fourth one, it is final demand caused production. Not production caused demand, but demand consumption caused how much our manufacturers must produce to provide all demand from final consumers and from other branches. So it is like we talk about client-oriented economy, yes, because we talk about that the first importance or primary importance has not production sector, but final consumers, yes, client-oriented economy. So it is the most important assumptions of input-output model. And now you can take a look on this table. So what we can see on this table. So probably I increase the scale. So what we can see all this, all our participants of economy. We can see that this table, sometimes we call this table like just input-output table, or sometimes we can find in some sources like table of inter-industry metrics, but it doesn't matter because the most important thing it is the rows and the columns of this table, not its name. So what we can see that we have our suppliers. So it is branches who will do some deliveries to other branches and to our final consumers. So we have that X1, it is our symbol, which we use to describe the full products or the full amount or summarize output of first branch, which this branch produce and can deliver to the same branch, first branch, to the second branch, and to the final consumers. So we can see that this amount of output can be delivered to different kind of other branches and to final consumers. So final consumers we can call also final demand, because we understand that final demand caused by final consumers. Then we can name our branches who will buy the products of the first supplier. We can name that like intermediate demand or intermediate clients. It means that we want to emphasize that this is clients from producers, this is clients from other sectors who need to produce own products, but they need to buy some, for example, raw materials from other sectors. So if we talk about, for example, the supplier sectors, about the second supplier, again, what does it mean X2? It means that all amount of products which can produce by second suppliers, this supplier can deliver to other branches and of course to the final consumers. So that's why we can name that all our X1, X2, which we put into this rows, we can find mathematically like a sum of products which we deliver to other branches, and we call it intermediate demand, plus sum of products which we deliver to final consumers, plus final demand. That's why we can find X1, so the general amount of products of first, for example, supplier of first sector economy, or we can name it like output of products, output of this type of products, the first supplier, like a sum, just a sum between intermediate demand and final demand. And mathematically we can write such formulas, or we can in short also use such formulas like 1.1, where we have xi, it will correspond with numbers of our branches which are suppliers, and it is equal amount as a general sum of their production. We can find like sum of what? Of products which we deliver to other branches plus how much products we deliver to consumer to final consumers. So we can say that when we talk about our rows into this table, we talk about structure of demand on some product, and the structure based on demand. So demand from sectors, from other branches, and from final consumers. But it is only one point of view, because when we talk about selling some products, we need to understand that we need to spend money to produce something. So we need to understand that each kind of our outputs we can calculate not from a point of view which based only on demand. We need to also explain these outputs from other hand, from which based on the costs. That's why we talk in, if we want to explain in terms of cost, we need to talk about not rows of this table or this matrix, but we need to talk about columns. No, sorry, but we talk about columns. And we also, what we can see this we can see this row, and we again use the same symbols and the same name, amount of output, or summarize outputs of each branch. So we have on this rows all branches, and on this rows we also have all our branches. And because of each kind of branch play double role, so being supplier and being clients at the same time, we need to find what? We need to find from 2 points of view our amount of outputs of each branches, and they must be equal to each other. So the first points you understand it based by demand. It is like a sum between intermediate demand and final demand. And now we need to describe the point of view which based on cost. So when we talk about producing some products or some goods, we need to buy raw materials. But what does it mean? We need to use raw materials. It means that we need to buy these raw materials. Who are our suppliers of these raw materials? It is another branches. So when we talk about how many delivers will do each kind of branches to another branches, it is from the cost point of view, means that, for example, first our branches must pay for such deliveries. We must pay, for example, for the first branch, for the second, for n branches, for their raw materials, which help us to produce our products. It is our costs. But what kind of costs? We know that we can group all kind of costs in, we divide to two groups. First group, it is direct cost, and the second group, it is indirect cost. So when we talk about payments for raw materials, it is direct cost. Always when we talk about payments for raw materials, it is always only direct cost. That's why all our intermediate costs or in other words, it is our payments for other deliveries from other branches, we called it as direct costs. Good, but when we produce our products, we need not only raw materials, we also need some equipment, we need some buildings, we need labor. So all these components we include in such economic indicators which we denote by V, and it's called added value or net product. So what does it mean, V? To produce some amount of products of first, for example, branch, we need to spend money for delivering raw materials, and then we also need to spend money for amortization, for salary, and you can find it into this place. So we need to spend money for salary, for amortization, and also when we will sell our product on the market, we need to put into our price what? Some rate of interest, some rate of our income. So, for example, if our total cost is equal $10, we can sell these products by $10. We will sell by, for example, $12. So 12 minus 10, it will be equal to $2, and $2 it is our what? Income. Yes, do you agree? So what we can see? We can see the double situation. First, it is situation when we explain outputs of each industry or branch based on demand point of view. And the other hand, we can see that we can find the amount of outputs of each branches based on calculation the all costs which we need to spend if we want to produce some amount of products. And that's why from one hand we use these formulas, and from the other hand we use these formulas where industry expenses and we denote it to describe the differences. It is X, Y. In this case, we will talk about xj, and we can define it like a sum between intermediate cost and added value. What is our intermediate cost? It is sum of all our payments for deliveries from other branches. It is our intermediate cost, and plus added value or net product, we will have our outputs from the cost point of view. So you can see that mathematically we can write such formulas where we summarize all our elements by columns, and in short we can write the second formulas where we can see that xj, we talk about the cost point of view, x outputs from the second point of view, like a sum between all deliveries or inter-branch deliveries. We can say that xij, it is inter-branch deliveries between one branch and another branch. No, between, for example, a good example, it is this deliveries x to 1. What does it mean? It means that second supplier will deliver some products to first supplier. Yes? In this case, first supplier will be deliver some products to the second branch. Yes? So in this case, if we mathematically we compare these mathematical formulas, and if we take into consideration all our assumptions, what we can see? We can see that for rows and columns must be prove the interbranch balance. And we can write it by using these formulas, where we put the first part, which based on demand, xij, sum of xij plus fi, so it is our sum of outputs based on demand, must be equal to what? Must be equal to outputs based on cost point of view. Sum of our deliveries, because all deliveries we must pay, plus added value. So it means, if we compare these two parts of equation, it means the sum of final demand must be equal sum of added value. And this name of interbranch balance. And the next part, to understand more clearly this probably table, and I want to describe simple model, and probably you will help me to put the right values into this model. So now I will copy some of information in this field. So the economy includes only 3 sectors. For example, so we want to describe some simple example, and if you help me to do in correct way this example, I will understand that we can go next. So the economy includes only 3 sectors. It, for example, steel, food, and labor. Yes, and we know some information that describes relationship between these sectors. So first of all, we know that to produce one new unit of steel, it requires 0.4 units of steel, 0.5 units of labor. Then we also know that one new unit of food requires 0.1 units of food, 0.7 units of labor. And also we know that one unit of labor requires 0.8 units of food, 1 units of labor, and 1.1 units of steel. So our matrix will have such view, yes, because we talk only about 3 sectors. So we have steel, food, labor, and we have steel, food, labor. Values we call our direct cost coefficients. So we can, this direct cost coefficients. So what does it mean, direct cost coefficients? It is a number of products of the I industry which is required for the production unit of the J industry. So we write this definition by using this example, and now we demonstrate how we can fill all these interbranch deliveries. Why we talk about these direct cost coefficients? Because when we talk about our expenses, about our intermediate cost, do you remember? Yes, when we talk about the payments for products from other branches, it is our costs, and we call this cost direct cost. And when we talk about this model, you need to know that it is our last consumption. All our coefficients or all these direct cost coefficients in this model are constant. It is last and very important assumptions into this model. So all our direct cost coefficients are constant, and they depend only on the technology way of production of each branches who are supplier. So in our model, we also in laboratory work number 1 will use the constant direct cost coefficients, and now you know what does it mean. And if we want to explain the next formulas, Xij, it is output of I industry that uses in J industry. So it is our interbranch deliveries. So if we want to find interbranch deliveries or outputs of I industry that delivers in J industry, what we need to use? We need to use this direct costs. That's why how we can define these interbranch deliveries, Xij, by multiplication between direct cost coefficient
by output of J industry that must be produced by using products from other industry. So again, you must recall how we denote our I sectors. I, it is our supplier sector, and J, it is our sector who buy some products from other industries. So it is our client. So what does it mean Xij? In this denoting of Xij, I, it is sector who will supply or who will make some deliveries, and J, it is someone of our branches who will buy or who will be our clients. So in this formula, our direct cost coefficients Aij reflect the requirements of each J industry to produce one new unit of its product, and Xij reflect the sum of product which J industry must produce. So now we need to add into our matrix of direct coefficients the output of each industries if we want to find the interbranch deliveries Xij. So in this case, in this matrix, you can see that our coefficients, it is 0.4, 0.5, 0, 0.1, etc. And we must multiply it by outputs of, for example, of steel, and we denote by S, of food, we denote it by F, or labor, we will denote it by L. In other words, we must multiply by sum of products which each kind of industry must produce by using information about the proportion of products from other industry which we need to use if we want to produce one new unit of our product. And now we are able to rewrite our formulas and use for each element of our matrix of interbranch delivery by using index A, Ij and Xj. So we can see that when we talk about the rows, the first rows about x1, a11 multiplied by x1, a12 multiplied by x2, a13 multiplied by x3, what does it mean? It means that we talk about the deliveries from steel industry, x1, to steel. Then from X1 to X2, so from steel industry to food industry to X2, and then from X1 again to X3, but in what amount of products which is equal to our direct cost coefficients and sum of product which each our client industry must produce X1, X2 and X3. And in the same way we can fill all these metrics.
So go next. If you know these formulas, if you understand these formulas, you can put these formulas into our first formulas where we describe our outputs based on demand point of view. So instead of sum of xij, what we can write? We can write instead of this multiplication. Yes, between between aij and xj. So if we put this into these formulas, we will get this kind of formulas. So we just put formulas 1.4 into formulas 1.1, and as a result, we get the formulas 1.5. So we can find that our outputs of each industry, we can define like a sum between our final demand and sum of interbranch deliveries. And then we also can form a system of equation, or we can use the vector form of these formulas. And in vector form, we can write these fundamental, probably, formulas, because in this way we find Leontief interbranch balance model, and we can write it by in vector form. By x it is equal the sum between our interbranch deliveries and our final demand. So x is this equal the interbranch activities, so like a sum between our direct cost coefficients and sum of outputs of each industry plus final demand. So if you understand all these moments, we can go to the central question of this input-output model. And central question is to find the changes in x, y if we will change our f, y by some delta. So how our productions will react on changes in final demand. So for this reason, we need to use very simple mathematical transformations. So we can use the system of linear equation, or I like to use vector form. And in this place, I use this simple actions which you need to do to understand how we transform this kind of formulas 1.7 to formulas 1.10. And x will be equal f divided by 1 minus a. 1, it is our identity matrix, and we need to use another symbol e. That's why x is equal f divided by e minus a. And from this kind of view, we can find the final formulas of x, which is equal e minus a. It is inversed matrix, yes, because you can see minus 1 degree multiplied by f. So it is just simply kind of mathematical actions help us to transform from formulas 1.7 to formulas 1.10. And we denote this inversed matrix e minus a -1, in degree of -1, inverted matrix, we denote by symbol B, and we called not only that it is inverse symmetric of Leontief, or sometimes we also called it like Leontief multiplier. So what does it mean? It means that this matrix have very important economical interpretation. Why? Because it will be our full costs. Full cost, it is our sum of direct costs and indirect costs. So this is inverted matrix. It is a matrix of coefficients of full costs or full cost coefficients, in short. So our matrix B we can call like inverted matrix of Leontief. We can call it like Leontief multiplier, or we can call it matrix of full cost coefficients. All elements of the matrix B show the need for the gross output of the industry and for the production of unit of final product of industry J. So it is when we talk about full cost, we talk about full or gross outputs which we need to produce if we want to sell to our not only final consumers but also for other branches. Okay, I think that it is all necessary theoretical information, and today we know the most important participants. We know about 2 points of view, how we can define the outputs of each industry when you are supplier, when you are clients. Also, we know that what does it mean interbranch balances, and we know that when we talk about double role of each industry, we can mathematically prove that some of our final demand must be equal added value or net product. Also, we know that according to the last our assumption of our outputs, all our direct cost coefficients are constant into our model, and also it helps us to simplify all our calculations and then mathematically find the central question of this input-output model. And the central question is lie in finding how our X will react on changing in final demand. And according to our all mathematical calculation, we know how to explain reaction of X by changes and in our final demand, and it helps us to find the central formulas of input-output model in vector form, and we will use these formulas to find the answers of your laboratory work number 1.